Hey, what's up guys, welcome back to the channel. On today's episode, we're continuing on our series with the best SDS rotary hammers, and on this episode, which is episode 15, we're going to be talking about this SDS rotary hammer again, okay? So, this is not deja vu. The reason I'm saying that's because on episode 14, we went over top to bottom of this SDS rotary hammer and put it on the test track, and to our surprise, it did not rank as high as we expected it to, considering the impact force delivered by this tool, okay? So, on this episode, which is episode 15, we are not gonna go over this tool top to bottom, but instead what we're gonna do is try to run this tool on the test track using this bit. Okay, it's a different manufacturer, but the important difference to know here about this bit is that it is a 4-cutter design and it has 4 flutes. And as you can see, the spiraling flutes are much closer together, and it looks like it should, in theory, be able to pull the dust it is grinding up or drilling through or bashing out, whatever you want to call it, out of the hole to provide better performance, right? So, before we get too far into it, if you want to know if this tool performs better, if you use the right bit for it, then stick with us. Alright, so as previously mentioned in episode 14, this tool ranked a whopping 9th place on the leaderboard, which was just not very high, even though it delivers 4.3 foot-pounds of impact energy, right? So, this bit right here, which is actually a Diablo bit, is a 4-cutter design with the flutes. And as you remember, and we can even throw up some previous clips if you want, starting on some of the holes, it started to get bound up. And the deeper it went, and we're only drilling about 6 inches here, maybe starting around even 3 or 4 inches, you started feeling a lot more of the resistance. Mainly just going to be burning up the bits, mainly because you can't clear the debris that's in the holes, right? And the main reason for that is mainly because the drill bits that we have been using on this series were the Makita 2-cutter design, which also had the 2 flutes, right? Which is not a problem if the rotary hammer spins fast, all right? So the no load RPM speed of this tool is 500 RPMs, right? But if you look at some of the other tools we tested previously up to this episode, which is episode 15, we had other tools which are spinning around 800, 900, 1,000, some even more than that. We had 1,400 RPMs, right? So those tools are spinning way faster, magnitudes faster than this tool. So those tools do not have a problem of trying to spin fast enough to pull the debris out of the hole, right? So this tool, I believe, is probably almost like a retrofitted SDS-MAX into an SDS-plus style. So it hammers hard, or it hits hard, but it does not spin fast, okay? So with the no load speed of 500 RPMs, it is the slowest rotary hammer rotational speed we've tested so far, which is why we think it ended up ranking in 9th place. So let's put this bit, 4-cutter bit on it, and let's go run the test. Alright, I know you caught those numbers because those numbers went by fast, and I will go ahead and apologize. We only ran this test once, mainly because the material we're using just did not have any additional surface area for us to run additional tests, okay? And I know we poured many of those at the time when we started the series, but those were actually poured when we were beginning the non-rotary hammer drills, right? As we were using what was like the 1/4-inch bits to do that. So those were actually not poured deep enough for these tests. So we do have additional pours on. We're just giving it additional time to cure. We are going to wet cure all of them as we have been doing. But the point is, we only ran the test once. And if you remember the leaderboard, the groupings of the runs that we do are usually very close together for most tools. And since we've already tested this tool, we could probably assume the same. Okay, so let's go take a look at it, right? All right, so this Bosch GBH18V-34CQN with the fully charged 8-amp-hour PROFACTOR battery on the first run went 10.37 seconds, okay? So we're just going to say that is the average, mainly because, you know, it's not going to differ too much from there. It may vary a little bit, but not too much. And as we're going to point out on the leaderboard, it's just using a completely different bit. So if you want to take it into account, do so. But if you don't do so, okay? So with the score of 10.37, where does it put it on the leaderboard? It goes actually in first place on the leaderboard, beating out the Milwaukee 2915-20 and the 2916-20, which are both M18 fuel tools with the 8 amp hour fully charged high output batteries. Okay, so let's go take a look at the leaderboard and look into the numbers. All right, so those first two runners had an average score of around 11.89, and the other one had 11.90. Let's just say that they're pretty much the same. Then they were followed up by the Makita XGT GRH07. All right, the both of the Milwaukee first and second place runners had an impact force of 3.6 foot-pounds of impact force, but their BPM was 4,600, one was 4,650, but their RPM was 800 and 810, okay? So if you calculate the work done per minute, they're roughly around 16,000 something, right? And then if you go take a look at this Bosch GBH18V-34CQN, the BPMs are significantly slower at 2,900, and its RPMs are also significantly slower at 500. But the impact force is 4.3 foot-pounds of impact force. Therefore, calculating the the energy delivered, which is going to be about 12,470, right? So let's go see how much of a difference that is between the same tool using the 4-cutter bit versus the 2-cutter bit, right? So the 2-cutter bit is actually in 10th place now with a score of 18.58. So if you take 18.58 and the improvement of this one with the 4-cutter bit, which was 10.37, that's almost close to like 46-48% improvement just using the different bit, right? The 4-cutter bit will actually grind up the concrete to be in the smaller pieces. The 4 flutes will pull it out faster. I understand it's a completely different manufacturer and has all these other variables into it, but the point is the tool is the same and did not encounter the resistance as you're drilling deeper into the hole to pull the material out, therefore getting better performance. Okay, so what can we say about this tool, right? So usually we'll go ahead and talk all about this tool, but let's go ahead and talk about the importance of using the right bits, okay? So this tool runs slower. When you're running slower, you definitely want the bit that's gonna be working for the tool. And slower tools, you definitely need to be able to pull the material out of the holes, which is why we went with the 4-flute, 4-cutter design bit, okay? So the only really important thing you can really take away from this is use the right bit for the tool. And this tool, as I mentioned earlier, feels like it would be an SDS-MAX tool, just an SDS-plus shaped form. And who knows, it probably is. I have no idea what they did on the Bosch side, right? But it feels like it would be. Also, the impact force is 4.3, so it will hit harder, okay? So, like I said, hope this video helped you guys out. If you want to take into account this tool on the leaderboard with this bit, then do so. But if you don't, then don't do so, right? I'm just here to give you the number. So, hopefully this helps give this tool, I want to say, unleash its maximum potential, right? But like I said, if you have any questions like that, let us know. Otherwise, have a great day, get back to work, and we'll see you guys next time.